Hey there, I'm using review exercise questions from page 91. Most of these exercises are relevant to your test. So let's start off with number 1. Find the limit as x approaches -2 for x cubed minus 2x squared plus 1. As a reminder, when you plug in a limit, you could just plug in the number to find the limit. Only time you can't do that is there's something wrong with it. In this scenario, there's nothing wrong with it. I could plug in a -3 and it doesn't cause any undefined or imaginary numbers. So -2 to the third power minus 2 times -2 squared plus 1, -8 minus 8 plus 1, -15. So again, you can always plug it in if possible, okay? So something like this one, number 2, let's just check if this one's possible. The limit as x approaches -2 of x squared plus 1 over 3x squared minus 2x plus 5. In this scenario, just trying to connect while we're here. In this scenario, we'll plug in -2. Let's see if that causes a problem. -2 squared plus 1 over 3 times -2 squared minus 2 times 2, -2 plus 5. Actually, I don't think this one causes a problem. So just remember, you can plug it in. Because they have a crazy thing on the bottom doesn't necessarily mean that you have to factor. So this is 4, 12, plus 4 plus 5. So that's 9 plus 12, 21. 5 plus 21, 5 over 21. Let's see. Okay, let's do this one. Number 5. 1 over 2 plus x minus 1 over 2 all over x as the limit approaches 0. Now the problem is, if I plug in 0 in this moment, this will become a 0. And you will have a 0 in the denominator, which is disallowed. It makes it undefined. So let's see if we could first rewrite this to make it a little better. So I'm going to rewrite this as 1 over 2 plus x minus 1 over 2 divided by x, which I could rewrite as times 1x, 1 over x, I should say. So I moved the x here over here, which is, this is divided by x, which is the same thing as multiplying by 1 over x. Now I'll distribute this 1 over x to everything here. So I get 1 over 2x plus x squared minus 1 over 2x. Okay. Now, if I could plug in a 0 here, I would, but it would cause 1 over 0, which is not good. So let's see if we could fix the top. So let's make the denominators common. Maybe that will help. So here, this has 2 plus x and an x. And here, this has a 2 and an x. So this guy needs just a raw 2. And I could tell the difference because these two were the original ones. And this guy needs a 2 plus x. Okay?
Can I just multiply by that? But if I didn't know that, then just multiply by 2x on that side and then 2x plus x squared on the other side?
Yes, and all it does is that you're going to have an extra x to cancel out. So it will work out anyway. Either way, 2 on the top over here. Let's do 4x plus 2x squared minus, this is going to be 2 minus, well, let's just do it like this, 2 plus x. And then this is over here is going to be 4x plus 2x squared. The denominators match. So I can combine the upper terms, right? Well, wait, 2 minus 2 is 0. So then I just have an x on top. 4x plus 2x squared. Well, look at that. Everything has an x. So now let me cross out an x everywhere. This gets lose an x, this loses an x, this loses 1x. So now I just have 1 over 4 plus 2x. Now you're like, okay, but the x is not gone, but we don't care. Remember, we just always want to make it so we are allowed to plug it in. Every step beforehand, I would cause a 0 on the bottom. Only at this moment, 0 is clear to plug in. So I'm going to plug in a 0 into here. Well, 2 times 0 is 0. So your final answer, 1 over 4. Okay. Number 6. As the limit approaches plus or minus infinity, I'll talk about how we're going to do that. 2x squared plus 3 over 5x squared plus 7. When your limit is approaching infinity, whether it's positive or negative, what you're going to do is you're going to ignore everything but the smallest, except the biggest power. As a reminder, is because as you go to infinity, a billion squared beats a billion. Or in this particular case, a billion squared beats just plus 3. So we don't actually care about this, okay? So we're only looking at this part right here. Let's say if I plug it in a positive infinity, 2 to the positive infinity squared over 5 to the positive infinity squared. These two naturally get canceled out because they're like on top of each other, right? It's positive, positive squared. So in this case, it is going to be 2 over 5. This is for the positive infinity, okay? If we're going negative infinity, 2 to the negative infinity squared. It will be. Yes, this is the evolved form of P over Q. Yeah. So because the powers were the same, they're the same. Yeah. So negative infinity, just to keep in mind, if you have negative infinity though, so this is negative infinity and negative infinity. So in this scenario, it's still negative infinity times negative infinity is positive. Okay? So that means it doesn't matter. And even if it mattered, they're both on top and bottom of each other. So they always cancel out the positive anyway. So it's also 2 over 5. So as the limit approaches both positive and negative infinity, you have a horizontal asymptote, which is what we used to call it before, but it's going to be 2 over 5, okay? Did you have any other versions? Okay, let's do 7 then. X to the 4th plus x to the 3rd over 12x to the 3rd plus 128. That can never really happen. In this scenario, it can never really happen because if you have positives on both top and bottom or negative on top and bottom, the negative on top and bottom will cancel out anyway. So usually they're going to be the same. Only in like a piecewise function that could really be different. All right, so for this one, 4x to the 4th plus x cubed. Yeah, oh, sorry. Yes, as the limit approaches both positive and negative infinity. And 12x cubed plus 128. Okay, so in this scenario, x to the 4th is the top dog here, right? X to the 4th is the biggest number here. Because x to the 4th is the biggest number by far, it's the only one that matters. Because when we're going to infinity, so billions, trillions, quadrillions, these start getting faded out, okay? So the only thing we care about is x to the 4th, right? But, so there was a rule from last year, if you remember, when P is only 1 bigger than Q. Does that feel familiar? It's only 1 bigger. It would be a slant asymptote. It is no, it's a slant asymptote like this. So it's a linear equation of some sort. I'm not gonna put that on your test. All right. Anyone else who's watching this, who knows? But I'm not putting that on your test. But for us, we're just going to call that. So if you do infinity to the fourth power, that would be infinity. So that would be our limit. Oh, here's a situation where it could be technically different. Since this is negative infinity to the fourth power, this is an even power, right? So this will be a infinity. Okay. But don't worry about something like that. All right. What's another one? We got to do one that's a squeeze. Where's the squeeze one here? Is that squeeze? No, that's not squeeze. Oh, let's do a trig one, actually. So let's say the limit as x approaches 0. This is made up. I don't know. This is not in the book. But let's say sine x on the bottom and then let's do tan x on top, okay? All right. If I were to plug in 0 in this case, I would get tan 0 over sine 0. Remember, it's at this angle on the unit circle, okay? So this is 1 comma 0. The slope here is flat, so that's 0 over the y value, which is 0. So you get 0 over 0. So you can't just plug in 0 if you wanted to, okay? So we're just going to have to use our trig rules to help us simplify this. So let's change tan to what?
Sine or cosine.
Good, sine x over cosine x divided by sine x, which you could rewrite
Sine x
as times 1 over sine x. I'm moving this one over here. Oh, but wait a second. If that's the 1 over sine x, we could cross these out. So all we're left is 1 over cosine x. If I plug in a 0 now, cosine of 0 is the x value. So it's going to be 1 over 1, or 1 in overall. Okay? So sometimes we got to use trig identities, okay? So it's that one, and the other trig identity, just keep in mind, sine squared x plus cosine squared x equals 1, and the two versions I mixed with it, the cotangent and tangent one. Okay? That's the only ones I would expect you to know, or I expect you need to know for the test.
Wait, 1 over cos x, how do you know that's
1
1?
over cos x. When I plug in a 0 into here, cos of 0 is the x value at that point, which is, or at 0 degrees, which is 1. Okay, let's see. You'll get some graphs where you got to talk about discontinuity and stuff like that, and limits and stuff. So let me just draw a real quick something. Yeah. So let's say you got something like this. Let's put an open circle here. Okay. So if I ask you what's the continuity at x equals 1, this case, it is continuous. There's no problem, there's no gaps, and no issues, right? If I ask you what's wrong with x equals 2, or the continuity of x equals 2, in this case, the limit as it approaches from the left side and the limit as it approaches the right side are not matching. So the limit as x approaches 2 from the positive is not equal to the limit as x approaches 2 to the negative. So it's discontinuous because of that thing. The three rules of continuity is that the limit has to exist, so aka both sides have to match, and the limit has to match the actual point. So for the next one, over here, at x equals 3, here the limit does match. The limit in this case looks like a, let's call it, looks like 1 from the lines I just drew now. But the problem is the limit as x approaches 3 is not equal to the actual point at 3. And we can tell that because that's the open circle and here's the dot somewhere else. Again, to describe continuity, the most basic thing is I can use one trace to draw it. If I have to make an open circle or I have to jump over here to here, then that's not useful. And also, just understand how limits exist in general. Like if they don't go to the same place, they don't exist. Let's go to another thing. Let's see, what else we got? Where's the intermediate value theorem one? Oh, from a piecewise function. So 3x plus 2 at x is greater than or equal to, or let's just say greater than 4. 7 over 2x at x is equal to 4. And let's just do 5x minus 1 when x is less than 4, okay? I might ask you on this piecewise function, is it continuous on this piecewise function, okay? If it's continuous on, and I should be specific, x of 4. If I say any other point, it would just be continuous because these are normal formulas, okay? But if I say, is it continuous at x equals 4, you just plug it into each one. And what do you need them to all be? Equal, whatever the result might be. So you plug it into the top one, 3 times 4 plus 2. That will give you the limit as it approaches from the x is greater than, so from the positive side. So 12 plus 4 is 14. This one, you plug it in. This will give you f of 4. So if this is f of x. So 7 over 2 times 4 equals 14. So that still matches. Then this one gives you the limit as it approaches from the negative side because we're talking about smaller. So this one, 5 times 4 minus 1, that's 20 minus 1, which is 19. So in this case, the limit does not match each other. So the limit doesn't exist. So if the question was, what's the limit at each part? You could say the limit as x approaches 4 from the positive side is 14. It's x is bigger than 4, so I'm coming from things bigger than 4. And then the limit as x approaches 4 to the negative side is 19. But if I ask you what the limit as x approaches 4 overall, that's a DNE. But the question I think that's going to be on the, or what should be on our test is it continuous? In this case, no. Okay? And that's because these two limits do not equal each other. Definitely something we should talk about is the rate of change stuff. So the rate of change, if I have some particle that's represented as d of t, so the distance it traveled over the time equals 6x squared minus 4. Okay? Where is it at exactly 2 seconds? Where is it at exactly 5 seconds? And where is it from between? What's the average between 2 and 5? So something like that, okay? So that's so, in this situation, I'm going to use the differential equation, which is f x plus h minus f of x all over h. Remember the x's cancel out, so that's why we do it like that. We're going to try to plug it in. So in this case, since I'm asking for exactly 2, I could plug in just 2, or I could keep it x and find the equation of it. If I'm going to keep it x and find the equation of it, then afterwards I could plug in 2. And since you got to do 2 and 5 in this case, it might be easier to find the equation instead of doing the big one twice. So we're going to do just the equation. So 6x squared, 6x minus h squared, plus h, my bad. Minus h is something else. Minus 4, minus 6x squared minus 4, all over h. This has to be FOILed out. 6x squared plus 2xh plus h squared minus 4 minus 6x squared minus 4 all over h. And then one last simplification, 6x squared plus 12xh plus 6h squared minus 4 minus 6x squared minus plus 4. So first off, let's just cancel out things by subtraction. 6x squared with a negative 6x squared, negative 4 with a positive 4. That's fine. So it's 12xh plus 6h squared over h. Wait a second, they all have h's. So I can reduce the h's. 12x plus 6h. Wait a second, my limit, I forgot to put this, the limit as h approaches 0. The limit is h approaches 0, so this will become 0. So my equation for the speed, or the velocity, is 12x. Which means, all I have to do is in this scenario, if at 2, I could just plug in 2. 12 times 2, 24. Plug in 5 here. 12 times 5, 60. Now, if I want the average speed of that, you could plug it in as the slope formula, where you plug in 5 and 2 in the answer, and then divide it by 3. But what you actually could do is just, you could take the average of the 2 speeds you found earlier. 60 plus 24 divided by 2, 84 divided by 2, 42. Once you get this equation, which, by the way, this equation, which you'll learn eventually, is called the derivative, but this equation is the equation for the speed, or the velocity. So I should call it v of t equals 12x. Okay? This, if I plug in 2, I'm getting the speed at exactly 2 seconds in. If I plug in 5, I get the speed at exactly 5 seconds in. Okay? So that gets you the velocity equation. I think that's the best way to do it. You could technically also just plug in the equation. Instead of x's, you could have plugged in the 2's. Yeah, because you will have to do it twice at least.
So if you're just asking for one, then that's the
Yeah, probably. Because then you get the answer straight away. Like you would just get 24 wrong. Because everything still cancels out the same. The only thing is that this 2 would have been a 2 at the end, which means it would have been 24. So, but everything cancels out. The thing that it cancels out as a pattern, you should keep that in mind because that's going to be useful later, okay? No need for this test, but for later. So, you see, are you good? I'll keep it up for a second. All right, and this is going to be a reminder of the asymptote stuff because the asymptote stuff is important for infinite limits. So let's say if we do this one. 2x squared plus 5x minus 1 over x squared plus 2x. Okay. Now I'm purposely going to ask you for certain limits. So what's the limit of this one as x approaches 0? 0. Limit of this one as x approaches positive and negative infinity. The limit as this approaches -2. We'll do that for now, okay? Okay. Now, what's the limit as it plugs in 0? If you plug in 0, it would all cancel out, so that's not very useful. If I plug in negative, or I have a 0 on the bottom. If I plug in a -2 here, 4 minus 4 on the bottom would cancel out. So let's do the infinity first, I guess, because that's kind of a little easier, actually. Remember, when it comes to infinity, we only actually care about the biggest powers. So in this case, it's just 2 infinity squared over infinity squared. Wait a second. Infinity squared on top and bottom cancel out. So you have a horizontal asymptote at 2, aka your limit as you approach it both positive and negative infinity is going to be 2. So this one's 2. Now let's see if we could plug in 0. Problem with plugging in 0 is, if I plug in 0, it doesn't work. So let's see if we can factor some stuff. This is going to cause some slide and divide. Or whatever you do. Wait, this one cannot slide and divide. Why would he give you this one? Let me check something. You can't slide and divide this one. So let's say you plug in 0, right? You'll get 0 on the bottom, and you'll get -1. When it's 0 over 0, that's an indication that you can factor something out. But in this case, it's not 0 over 0. So because it's not 0 over 0, that actually gives us a different message it tells us. That tells us that there's a vertical asymptote there. So what I'm going to do is set the bottom equal to 0, okay? So I'm going to have x squared plus 2x equals 0. I'm going to take out x's, and then I have x plus 2 equals 0. And then my two answers should be x equals 0 and x equals -2. Okay, what does that mean physically? Physically, that means on the graph, what happens? Do you know? You have what kind of things? Not horizontal in this case, vertical asymptotes. One at 0 and one at -2. Okay? Now, your graph could look something like this, or like this, or something like that. So we got to figure out what we're going to do with that. So in this case, the best thing we could do is, first off, you could technically take your calculator, just graph the picture, and see, oh, these are going separate directions? That does not exist. Or, if they're going the same direction, in this case, if it looked like this, it would be a positive infinity as your limit for -2 in that case. I'm looking at -2 in this. Okay? But if it looked like something like this, let's do it here. Something like this, then in that situation, that would be negative infinity. It's going down. They have to go the same direction for it to work. So either you can put it in the graph and calculate it, or see it, or what you could also do is just plug in something really close to 0 on both left and right, kind of like we did it in the first lesson of the section. So you could plug in like 0, 0, 0, 1, see if it gets really big or really small, and plug in something smaller than that, which is -0.001. And see if it gets really big or really small. Okay?
Charles, ILO to high school office. Charles, ILO to high school office.
Right. That does not cover technically everything, but that's how it is now.